I am a researcher. I've done research since the fall semester of my freshman year in Dr. Booker's lab, and I've dedicated most of my spare time to it. My project studies enzymes, little biological machines that synthesize antibiotics. The research aspect isn't always fun, especially when I run into dead ends. However, I enjoy working with the people in my lab. We use E. coli bacteria to produce the enzymes we need. E. coli are grown in these large flasks of growth medium, giving them the resources to grow and make the enzymes. This is the autoclave, which is like a giant oven that heats and pressurizes the flasks, killing any live microbes and sterilizing the growth media. Here, we are making cobalamin, a form of vitamin B12 that is necessary for our enzyme to function properly. Here are some more nutrients we need to add. This is one of our shakers where we spin the flasks at a warmer temperature to facilitate bacterial growth. After having prepared the nutrients and media, all that's left is adding everything together. There are two tools we use, a pipette for smaller volumes and a graduated cylinder for larger ones. I started doing research mainly to bolster my medical school application. I figured getting a paper published wouldn't be too hard. But research isn't a beautiful thing that rewards your hard work. Frequently, projects hit dead ends, where competing labs publish their data and conclusions first, nullifying all your hard work. My project had hit a dead end for about a semester until we finally developed a solution. After a few weeks of progress, we ran into another wall, which we have yet to break through. This frustrating cycle of moving and stopping is research. I spend about 15 to 20 hours a week at my lab. This time commitment has forced me to prioritize my time. Sometimes, this means I can't hang out with my friends because I have to wake up early to do experiments at lab. Other times, I must skip lab to prepare for exams or projects. Research also nags at me. When I am stuck on a question, it will frequently stay in my head, forcing me to come up with solutions, sometimes to no avail. However, all researchers are in the same boat. We are all trying to answer fundamental questions or discover new things that could improve people's well-being and progress society forward. After letting the bacteria grow overnight, we pour the bacteria and media into centrifuge flasks to prepare to harvest them. This is the centrifuge we use, and we spin the solution at a force of 7,500 Gs to get all the bacteria to clump into a solid paste. At the bottom of the flask is the paste. 4 large flasks equates to roughly 3 cycles of the centrifuge. Here's the final product of the cell paste. The solution is boiling because it is liquid nitrogen, which we use to instantly freeze the cell paste. This protects the enzymes inside from oxygen. Next, we must run a gel to detect the presence of our enzyme. These are the solutions and gel caster we need. Here, we are pipetting the gel currently in a liquid form to the holder to allow it to solidify. The gel is important because in addition to allowing for detection of our enzyme, we can see how pure it is by analyzing how many other stain bands there are on the gel. After running the gel, we must stain it, which is shown here. Similar to photographs in darkrooms, we let the gel sit in a blue stain overnight, allowing the particles to bind to the stain. You might be thinking this stuff is pretty cool. However, I use many of these techniques on a day-to-day basis, and the appeal quickly degrades. Research isn't always fascinating. It has long periods of boredom. When my project first got started, I was so excited to run gels to see if I extracted my enzyme correctly. Now that my project has been stuck for a while, even after testing many different conditions, the excitement and anxiety has faded, but the core feeling of maybe this time it will work remains. Shown here is the gel after destaining. The staining process turns the whole gel blue, and destain removes the excess dye. As you can see, there are multiple bands in the gel, each representing different enzymes. I believe that I have come a long way since first beginning research. My goals for research have changed from just trying to get published to actually understanding and resolving problems to progress my project and the general field forward. Although it is hard not always having free time and being frequently frustrated with science, I cherish the people in my lab, the things they have taught me, and the memories I made with them. I've become a better critical thinker and learned to comprehend difficult scientific literature. I am a researcher, and the techniques and lessons I have learned here are an invaluable part of me.